What if ancient tattoos were never meant to be seen as simple decoration? What if the marks beneath the skin were part of a system, one that connected pain, identity, healing, memory, and community? Thousands of years before electric tattoo machines, people were puncturing or cutting the skin with tools made from bone, stone, horn, shell, and metal. They pushed soot, charcoal, ochre, and other pigments into the wounds, permanently changing the body. To modern eyes, the result looks like art, but to the people receiving those marks, the experience may have been something much larger: a declaration of adulthood, a sign of rank, a record of belonging, a request for protection. Perhaps in some cases, an attempt to control pain. This has led to a provocative idea. Could an ancient tattoo have functioned like a biological interface, not an electronic device? Not a hidden circuit capable of storing literal ancestral memories. There is no scientific evidence for that, but an interface in a more human sense, a place where an external symbol was physically inserted into the living body, triggering nerves, blood, inflammation, healing, memory, and social recognition all at once. The real science may be less supernatural than the myth, but it is no less fascinating. More than 5,000 years ago, a man died in the high Alps. Today, we know him as Ötzi the Iceman. His naturally preserved body carries 61 known tattoos, most arranged as groups of dark parallel lines or crosses. They appear around the lower back, ribs, wrist, knee, calves, and ankles. Many were placed in locations normally covered by clothing, making it difficult to explain them purely as visible decoration. Several of those regions also showed signs of physical wear or possible chronic pain. Because of this overlap, researchers have proposed that at least some of Ötzi's tattoos may have had a therapeutic purpose. They may have marked painful areas or formed part of a treatment involving repeated puncturing of the skin. That theory remains plausible, but it has not been proven. We cannot ask Ötzi why the marks were made. Similar placement does not automatically demonstrate that the tattoos relieved pain, and comparisons with later acupuncture traditions must be treated cautiously. The evidence allows us to discuss a possible medical function, not to declare that prehistoric Europeans had already invented acupuncture. Even the method used to create Ötzi's tattoos remains under investigation. For many years, the popular explanation was that someone cut fine incisions into his skin and rubbed pulverized charcoal into the wounds. More recent experimental research has suggested that at least some of the marks may instead have been produced by repeatedly puncturing the skin with a pointed tool, possibly made from bone or copper. The important lesson is not that one theory has completely defeated the other. It is that ancient tattooing was technically diverse. There was never one universal prehistoric tattoo method. Some cultures used a single sharp point and inserted pigment dot by dot. Others used several points attached to the same handle. Some cut the skin and rubbed pigment into the incision. In some northern cultures, pigment-covered thread or sinew was drawn beneath pinched skin. Hand tapping, the method in which a comb-like tool is struck with a second instrument, was especially associated with Oceania and parts of Asia. It should not be projected onto every ancient tattooing culture in the world. The archaeological evidence for these tools is rare because skin, wood, fiber, and many other organic materials decay. But occasionally, the past leaves something behind. At the Fernville Archaeological Site in Tennessee, researchers studied sharpened turkey bones dating approximately from 3500 to 1600 BCE. Microscopic wear patterns and pigment residues indicated that some of these tools had been used for tattooing. Black and red pigments were found in association with them. These were not crude objects used randomly. They were purpose-shaped tools whose wear recorded repeated contact with skin. In the Pacific, researchers have identified obsidian tools bearing wear and residues consistent with skin puncturing around 3,000 years ago. In Iron Age Siberia, high-resolution near-infrared imaging of Pazyryk mummies has revealed remarkably sophisticated tattoos. Researchers studying the lines concluded that different points or multi-point tools were probably used to produce different widths and details. The work was precise enough for researchers to distinguish differences in technique and potentially even the work of different tattooists. Ancient tattooing was not merely an impulsive act. In some societies, it was a specialized craft requiring planning, skill, practice, and knowledge of how skin responds to repeated injury. This is where the bone needle becomes a biological bridge. Imagine the scene. There is no electric motor. No sterile cartridge vibrating thousands of times each minute. A person holds a sharp point or a small comb made from bone, horn, shell, or another hard material. In a hand-tap tradition, another person strikes the tool with a mallet, driving its points into the skin. Tap, lift, reposition, tap again. Blood appears. Pigment enters the wound. The receiver feels every impact. The person making the tattoo must control depth, direction, spacing, and force. Too shallow and the pigment may disappear during healing. Too deep and the damage, bleeding, and risk of infection increase. This process creates sound and rhythm, which may become an important part of the experience, but we must separate a reasonable observation from an unsupported claim. There is currently no established evidence that ancient tattooists intentionally used a specific tapping frequency designed to match the resting heartbeat. A normal human heartbeat is not a single universal rhythm. It varies between individuals and changes with fear, pain, physical condition, temperature, and emotion. Nor did every ancient tattooing method involve audible tapping. Some traditions relied on direct hand poking, incision, or subdermal stitching instead. However, this does not make rhythm irrelevant. A repeated sound can structure time. It can signal progress through a difficult procedure. It can coordinate the movements of the tattooist and assistants. It can transform a sequence of painful punctures into a recognizable ceremony. When people sing, breathe, chant, drum, move, or endure discomfort together, rhythm can help organize attention and create a powerful shared experience. Ancient tattooing may therefore have felt neurologically intense without being a coded neural technology. Every puncture activated sensory receptors in the skin. Pain signals traveled through peripheral nerves toward the spinal cord and brain. The body reacted immediately to tissue damage. Blood vessels changed their activity. Clotting began. Immune cells entered the injured area. During healing, macrophages and other cells interacted with the foreign pigment particles deposited in the dermis. A tattoo becomes permanent not because the ink has connected itself to the nervous system, but because much of the pigment remains trapped within the deeper skin and is repeatedly captured by cells such as macrophages and fibroblasts. In this sense, a tattoo is genuinely biological. It is not paint resting on the surface. It is a long-term relationship between foreign particles and living tissue. The skin heals around something that was deliberately placed inside it. The immune system responds, but it does not completely remove the mark. Some pigment can also travel through the lymphatic system, which is one reason tattoo pigment has been detected in lymph nodes. Ancient tattooists could not have described macrophages, fibroblasts, inflammation, or sensory neurons in modern scientific language, but generations of practical experience may have taught them which materials remained visible, how deep a tool needed to penetrate, which wounds healed well, and which techniques produced infection or excessive scarring. They did not need laboratory biology to become skilled observers of the human body. Knowledge could accumulate through demonstration, apprenticeship, failure, and tradition. This is also where charcoal enters the story. Black pigments used in ancient tattooing could include soot, charcoal, or other carbon-rich materials. Red pigments could include ochre or iron-rich earth. Because carbon is used in modern electronics, it is tempting to imagine that charcoal particles beneath the skin formed conductive pathways. But ordinary ancient tattoo pigment was not a functioning biological wire. Carbon's electrical properties depend heavily on its structure, purity, arrangement, concentration, and connection to a wider circuit. Loose soot or charcoal particles trapped among cells do not automatically become an electrode capable of reading nerves or transmitting memories. Modern temporary tattoo sensors use specially engineered conductive substances such as graphene, metallic inks, or conductive polymers, together with design circuits and external electronics. That is fundamentally different from placing soot inside a wound. So charcoal-based tattoo pigment was probably selected because it was dark, available, stable enough to remain visible, and culturally meaningful, not because ancient people had discovered hidden bioelectronics. Yet calling the pigment merely aesthetic ink may also miss the point. Its physical role was simple, but its social role could be enormous. Once beneath the skin, the pigment made an invisible idea visible. A community could place ancestry on the body. A warrior could display achievement. A healer could mark a painful location. A family could recognize affiliation. A ritual specialist could inscribe protection, obligation, or transition. The particles did not electrically conduct ancestral memory. The symbol carried memory because people agreed on what it meant. That distinction is essential. Memory does not have to be stored inside the pigment to be activated by the tattoo. Consider a mark received during initiation. The person remembers the pain, the sound of the tools, the voices of relatives, the fear before the first puncture, and the relief when the process ends. Other members of the community recognize the pattern. They understand that the wearer has passed through a particular experience. The tattoo becomes a permanent cue capable of reactivating memories in both the wearer and the people who see it. In this way, it can transmit information across time without containing information in the manner of a computer chip. The skin becomes a social archive. The body becomes evidence. The pain of making the mark may have increased its importance. A symbol drawn with removable paint can disappear. A symbol created through hours or days of controlled injury carries a different weight. It demands commitment. It creates a cost that is difficult to fake. The wearer has not merely chosen an image. They have endured its creation. This may help explain why tattooing has repeatedly appeared in rituals involving adulthood, courage, rank, spirituality, mourning, protection, and belonging. But again, no single explanation fits every culture. The simple lines on Ötzi are not the same as the elaborate animal imagery of Pazyryk mummies. A therapeutic mark is not identical to a status symbol. A protective tattoo is not identical to a record of military achievement. Ancient people were as culturally diverse as people are today. A tattoo could have been art. It could also have been medicine, identity, ritual, memory, or several of these at the same time. The modern return to traditional hand-poking and hand-tapping techniques is therefore revealing, but not because it has scientifically uncovered a forgotten neurological frequency. What it reveals is the difference between receiving an image and undergoing a process. An electric machine can apply pigment rapidly and precisely. Traditional techniques may be slower and create a more noticeable sequence of individual punctures or impacts. The tool, sound, physical positioning, presence of assistants, and cultural rules can all make the act feel ceremonial, but the significance does not come automatically from the technology. A hand-tap tattoo performed without cultural context is not guaranteed to reproduce the meaning of an ancestral ritual. Technique and tradition are related, but they are not interchangeable. A tool can be copied. A worldview cannot be reconstructed so easily. This is especially important when discussing indigenous tattoo practices that remain alive today. They are not laboratory experiments or relics frozen in the past. They belong to living communities with their own authorities, histories, responsibilities, and meanings. Calling them remnants of a mysterious global nervous system technology would erase the specific cultures that created and preserved them. The evidence leads us toward a conclusion more grounded and perhaps more powerful than the original fantasy. Ancient tattoos were not known bioelectronic circuits. They did not literally record ancestral memories in carbon deposits. Bone tools were not proven to strike at a universal heartbeat frequency, but tattooing did create an extraordinary junction between biology and culture. A sharp object crossed the barrier of the skin. The nervous system registered pain. The immune system responded to injury and pigment. The body rebuilt itself around a permanent foreign material. The mind attached the experience to fear, endurance, care, identity, or transformation. The community interpreted the completed mark. That is a biological interface. Not one built from wires and software, but one constructed from wounds, particles, nerves, healing, memory, and shared meaning. Perhaps the real ancient technology was not the pigment, it was the process. People learned how to use pain without allowing it to become uncontrolled injury. They learned how to make the immune system preserve a visible mark. They learned how to transform an individual body into a surface that could communicate with an entire community. And they learned how to make that message last long after the moment of its creation. Thousands of years later, much of the original language has been lost. We can see the lines. We can examine the tools. We can identify some pigments. We can map where the marks appeared and reconstruct how they may have been applied. But we cannot always recover the exact words, rituals, stories, or promises attached to them. The code is still visible. The dictionary is missing. So perhaps the most accurate question is not whether ancient tattoos were advanced machines hidden beneath the skin. It is whether the human body was one of our earliest information technologies, a surface that could be modified, a record that could move, a symbol that could age with its owner, a message protected not inside stone, wood, or metal, but within living tissue. Ancient tattoos were not electrical circuits. They may have been something more deeply human. A bridge between sensation and meaning, between suffering and belonging, and between a temporary life and the memory of a people.